I'm sorry about that. I was interrupted by some people coming to my house. Um, we'll continue where we left off. So this function here, if we run it in the interactions area, will produce this tree image. But we've also defined it. So I can just type tree, and I can also type tree2. Whoops. They're exactly the same. But that's not so good. We can only make this one tree. We can't make a tree, with a circle. I can make a tiny one. Let's make it really small. You can hardly even see it. Or I can make a really big one. This is going to be too big. Yeah, I can't even see the whole circle. But we can't do that with our tree because this tree is just a piece of data. In this case, it's an image data. And even this, when this function above triangle 50 solid dark green, rectangle 1020 solid brown, when this function is evaluated, the value of that function is this image. So these two things are actually identical. And what we would like to do in this club is, or in this next lesson, is to figure out how we can make a function that will make a tree, so that we can give it a number that represents what size it is. So what we're going to do in club is to kind of abstract some of this out. So if we look at this tree and think that the proportions are the way we want it, what we would need to do is figure out what is the relationship between the length of the side of the tree, of the triangle, and the width and height of this rectangle. So we can use Dr. Racket to help us with that even. So if the triangle is side length is 50 and the rectangle's width is 10, what is that relationship? Well, we can divide 50 by 10 and we get 5. So we know that the tree's side, or the triangle's side length is 5 times longer than the trunk's width. And we could find out about the height as well, how it relates to the, actually we can make the trunk proportional to itself if we want to. It's twice as high as it is wide. We can see that pretty easily. So maybe what we could do is say, let's just do the trunk first. That's the easiest part. So when we're defining a function, it's going to look a little different. We still use the word define, but then we have to put the name of our function in parentheses. So I'm going to do trunk, and we're going to give trunk a size variable. So what we're doing here is we're making a little template that's saying we're defining a new function called trunk, and it will be given a size. And in fact, here's what I would like to do. Trunk, it takes a positive number, and it returns, I'm using that arrow because a function takes one type of data in and transforms it into another type of data. Sometimes it's the same kind of data, but there's always some kind of transformation that happens, even if nothing actually changes. That's a kind of a funny concept, but it's going to take a positive number and it's going to return an image. So this is a way that we can kind of think about the design of our function. Our function has the name trunk, and we give it a positive number, and we expect to get back an image from it. So we need to figure out how to do that. Well, how do we get the image out? Well, we know that we want our trunk to be a rectangle, so we're going to use the rectangle function. And we're supposed to give it a number here and a number here, and we know we want it to be solid. We know we want it to be brown. If we want to have this part changeable, we would add another variable to our function. So these two numbers that I just put dots in, we need to figure out how to take a single number from size and get out the two numbers that we want. So usually what I do is I start with a concrete example like this one, rectangle 10, 20. If I give a single number in size, how can I turn that number into a 10 here? And how can I turn the other one into a 20? Well, let's say we gave it size 10. Well, I know then that this would just be size, and this would be size times 2, right? So basically, what I would expect from this function is that, and actually we can make a test for it. So we can say equal. This can tell if images are equal or not. And what we could do is say we expect trunk 10 to equal a rectangle with width 10, height 20, solid, and brown. So if this ends up being true, then we know that our function works the way that we expect it to. Oh, look, we got true. So trunk 10 will give us this rectangle. Let's try it. Trunk 10. Oh, let's try trunk 20. It's even bigger. Trunk 1. Oh, it's really tiny. Trunk 100. There. And the thing is, each one of these trunks has the same relationship. The width is half the size of the height. And that's because we made this function called trunk. Okay, so what if we want to make a tree now? If we want to make a tree, define tree size. We want to say tree is a function that takes a positive number and it returns an image. So it's exactly the same as trunk. And one of the nice things is the trunk is part of the tree, so we can use that. But we know that to make the tree, we have to use this kind of form. So we will type above triangle, and I don't know what this is going to be. I don't know what it's going to be yet, so I just put a placeholder. I do know I want it solid and dark green, and then we want to make a trunk, and let's just do size. So basically, like if we gave this tree size 10, we know we're going to get this trunk here, which is the same as this. So how do we make this into 50? Well, if we say that size is 10, what times 10 is going to give us number 50? Well, we could find out by going 50 divided by 10 is 5. So to get the size of the triangle, do times 5 size. Okay. So now we have a function like this, and we can actually make another test. So tree 10 should actually be the same as this image here. we can compare those two things. So I expect this to be true. So when I run the program, I should get the word true 2 times. And if I don't, then I know something was wrong. Oh, tree, this name was defined previously and cannot be redefined. Okay, so that's because I defined it as a variable up here. So I will just delete that. And in fact, we don't need this stuff anymore because we have a function that can do it for us. Yep. So I wrote a test for this because what I wanted was I wanted to be able to make this rectangle trunk by using this function. I wanted to be able to make this tree by using this function. So now I should be able to do, instead of tree 10, that doesn't work, tree expected a function call, but there's no open parentheses before this function. Oh, thanks, Dr. Racket. Tree 10, tree 20, tree 5, tree 1. Oh, it's so tiny. Tree 100, big tree. And there you go. We now have a function that can make trees of different sizes that will all have the same proportions. And all we did was a tiny bit of math. So the idea for Club is to design a couple composite shapes like this, and then figure out the relationships of the sizes of the shapes, and write a function that we can give a size value to, so that we can make our own shapes as big or small as we want. And again, let's say we want to be able to make the leaves different colors. Leaf color. We could replace this here, but then we would have to do, in order for it to be equal, we'd have to do that. But now I could do tree 10 orange, tree 10 aquamarine. So lots of fun that can be had. I guess this is getting long. We've got like 20 minutes of video now. Thanks for watching. I hope you learned something. Goodbye.